evening, Josh. Evening, Doc.
Evening, engineer.
Good evening. So tonight, it's already late. We're going to discuss about still differential calculus, but our topic is on time rates. Okay. Now, time rates is, let's say, a certain quantity is a function of time. So that is time rates. Let's say, for example, a certain quantity of x is a function of time. Okay. So the rate of change of that quantity will be denoted by the expression of dx dt. Okay. Now, when two or more quantities, okay, all are functions of t, of course, are related by an equation, the relation between the rates of change may be obtained by differentiating both sides of the equation. Let's say you have y squared is equal to x squared, which are both quantities or functions of time. So when you differentiate both sides of the equation, you get 2y dy dt and 2x dx dt. So, of course, one of these is actually given. One of the quantities has a given rate of change with respect to time. So, in differentiating both sides of the equation, you can find the rate of change of a certain quantity, either x or y. So that's the expression of time rates. It's a quantity, a function of time, wherein its change can be denoted by the function or can be denoted by the term dx dt. Okay. Now, to better understand this type of aspect of calculus, we are going to solve some worded problems. Okay. Now, I think we have a few problems written that we will be solving today. Okay, so I'll be solving the first problem, Josh. Now we are going to solve only problems pertaining to triangles for today. Okay, so the first problem, let's start. Okay, it states that one leg of a right triangle is always 6 feet long, and the other leg is increasing at the rate of 2 feet per second. Find the rate of change of the hypotenuse when it is 10 feet. Okay, so first we illustrate the problem. So you have a triangle. Okay. Now you can denote. Wait, I'll be going back to the problem. Okay. So it's up to you to select which is the leg which is not moving or not increasing. Since it's not mentioned in the problem, if it's the leg going to the right or the leg upward and so on. So in this case, you could select if this one or this one, you could select which one of the legs is not increasing. So let's say I'll be selecting this one. So I repeat, in other problems, you cannot interchange. Okay, if this is the value increasing and the value decreasing, it is mentioned in the problem. But in this case, it's not. It only states that one leg of a right triangle, meaning you can select either of the two. Of course, not this one. This is the hypotenuse. Okay, so let's say I'll be selecting this one, my y, as 6 feet. So this is the leg which is not increasing. Okay. Now the other one, this one is moving, okay, or is increasing at the rate of 2 feet per second. Okay, so let's say I'll be denoting this as x. Therefore, your change is dx dt. So this is 2 feet per second. Okay, and at a given measurement of your hypotenuse, which is equal to 10 feet. Okay, so these are the conditions. Your y is 6 feet by your selection. Okay, it's not moving, it's not increasing. And then your x is moving at a rate of 2 feet per second or increasing. And then, of course, your hypotenuse will also be increasing. So we denote this as, let's say this is your hypotenuse. We denote this as dh dt. Okay, so we do not know the value. So this is what we're going to look. Rate of change of the hypotenuse when it is 10 feet long. Okay, starting from 10 feet. Okay, now let us solve first for the value of x. Okay, hopefully you could see it here. Okay, solve it here. So your x now, x squared is equal to the square root, no, later, h squared minus y squared. So there will be no cut in the solution. Your x now is equal to the square root of h squared minus y squared. Replacing the values, x is equal to the square root of 10 squared minus 6 squared. So this is equal to 100 minus 36 equal to 64. Square root of 64, or x is equal to 8. So we have the value here of 8 feet. Okay. Now, since your y is not increasing, therefore its change is equal to 0. Your dy with respect to dt is equal to 0. Okay, so we have our values. So your y is 6 feet. It's not changing. Therefore, its rate of change with respect to time is equal to 0. Your hypotenuse at 10 feet, it increases since your x increases, but we do not know the value of its rate of change. So this is the one we're looking for, okay? And your x now, we solved it using Pythagorean theorem, has a value of 8 feet. Now, it is given also that it is increasing at the rate of 2 feet per second. Okay, since it's a triangle, we're going to use Pythagorean theorem. So h squared is equal to x squared plus y squared. So like I said, if they're all functions of time, you differentiate both sides of the equation. So differentiating h squared, we have 2h and then dh equal to 2x dx dt and plus 2y dy dt. Okay, now if we're going to input the values, okay, so we know that dy dt is equal to 0. Therefore, 2y multiplied by dy dt is equal to 0. Okay, now let us input the values that we have. So we have 2 multiplied by your hypotenuse, 10 feet, and the one we're looking for, dh dt, is equal to 2 multiplied your x, which you have computed, equal to 8. And then the rate of change of x with respect to time is 2 feet per second. Okay, so this is equal to. Okay, isolating dh dt, hopefully it's still visible, Josh?
Yes, visible. Visible.
Okay, so we have dh dt equal to, this is 432. Okay, so 32 all over, then cross multiplying, this is equal to 20. Okay. So we could cancel 4. This is 5. This is 8. Okay. So your dh dt now is equal to 8 over 5. Or what's the value of this, Josh? 6? 1.6 feet per second. Hopefully, it's still visible in the screen.
Still
Can you
visible.
still see it? Okay. So the main The main purpose of the problem is to look for the rate of change of the hypotenuse. Now I'll be running down the problem again. So we're given two values. One is one leg of a triangle, which you can select. It's not identified in the problem. So you could select. So I selected this one. And then at 10 feet, the rate of change of x is 2 feet per second. Now, we have to solve for x first. So the first step is solving for the missing value of the triangle. We have 6 and 10. So we could solve x using Pythagorean theorem. We got the value of 8. Okay. Now, the rate of change of y is equal to 0 since it does not increase. It's mentioned that it's not moving, it's not increasing. Therefore, its rate of change is equal to 0. Now, x is given at 2 feet per second. Now, we're looking for the rate of change of the hypotenuse. Now, using Pythagorean theorem and differentiating both sides since they are functions of time, so we could have this value. And then, since dy dt is equal to 0, there's no change. So 2y multiplied by dy dt is equal to 0. And then inputting the values, hypotenuse of 10 and x is 8, and then your rate of change of dx dt is equal to 2. So just manipulating the equation, we get the value of 1.6 per second. That's increase of the hypotenuse of the triangle. Okay, so hopefully, Josh, it's clear. Okay, now we actually all the problems have similar types of computation. So you could try the other one. Okay, the problem states that one end of a ladder 34 feet long slides down a vertical wall while the other end moves away from the wall, okay, horizontally at the rate of 3 feet per second. How far is the top of the ladder? Is it how far? Covered by the monitor. Okay. Descending when its foot is 16 feet from the wall. So I think you have illustrated the problem.
Opo. Okay.
Okay, so ladder 34 feet, yes, 34 feet, and then 16 feet from the wall. So in this problem, 16 feet is in the x-axis. Okay, so unlike that, my problem, you could denote 6 in either of the two, but in this case, no. It should be in the x-axis.
Opo.
Okay, so try solving it, Josh.
Differentiate. Eh,
Josh, before differentiating, try to solve first for the missing side of the triangle.
missing side. Y. Equals minus 30. Differentiating this formula. I'll just prepare. Differentiating this formula. Since h is constant, dh dt is 0.
Okay, since the ladder is not
Wait.
increasing in length, the HDT is equal to 0.
Transposing this term, you can get 2x dx dt equals negative 2y dy dt. 2x 2x should be increased to negative 2 times 16 times 3 equals negative 2 30 times dy dt. Isolating dy dt.
Okay.
To 1.6 feet per second.
Okay, so the answer is negative 1.6 feet per second. Now the negative signifies the direction of the ladder, of one side of the ladder, which is going down, going towards the negative y-axis. So it's correct. If it's positive, meaning the ladder is going up. Now in this case, it's negative, so the other leg of the ladder is going down. Okay, so very good. Okay, so let's try the other one, Josh.
Check.
Okay, so third problem states you are observing a rocket launch from an observation post 5,000 meters from the launch pad. When it reaches an altitude of 10,000 meters, it is traveling at the rate of 200 meters per second. How fast the rocket can't read that part, away from you at the moment. What's that word, Josh? It's covered by the screen.
Moving away.
Moving away. So how far is the rocket moving away? So we're solving for the hypotenuse of the triangle. Okay, Josh, could you show the illustration?
Fine. So just put here H unknown. And then unknown. So we can solve for H. Square root of 5,000 squared plus 10,000 squared. Just approximately 11,000. Meters. And then differentiate. Can express this alternatively.
Okay, you're going to try another solution by differentiating the radical. Okay, square root of x squared plus y squared. Okay.
Negative 1/2 and then chain rule. 2x. Since x is constant,
Josh, kindly indicate in the illustration. 5,000 is equal to x, and then could you write, dx dt. Dx dt is equal to 0 in the illustration using your red marker. Like, see, your hypotenuse is dh dt is equal to the unknown, and then dy dt is equal to 200, so this is equal to 0 meters per second. Okay.
So we can remove this term and simplify. Go in the denominator. 2y. And then we can substitute.
Josh, you forgot the rate of change of y, dy dt. 2y multiplied by dy dt.
It was 20,000 over 2. This is actually, this term is h. So we can already put 1.1 and equal that to just 300.
Josh, write your answer on the lowest part, and then don't erase it later. Right side, lowest right of the screen. Okay. Write your answer.
20,000 times 178.885 meters per second.
Okay, now let's discuss the solution first. So you differentiated the hypotenuse using the square root of x squared plus y squared. Okay, it's still an acceptable approach. Now let's see you try to solve it using my solution. Another approach. Let's see if we have the same answer. Okay, kindly erase your solution. Then let us see using the solution I was using.
Alright. So, again, PP,
So we have the value for
value pala.
age now. Isn't it? It is 11,180 point. Yes, but we will use that value 0.339. So that we're not going to solve it anymore with using Pythagorean theorem. 80.339. Okay. Just 3 decimal places, Josh. 339 will be fine. Actually, we only use 2 when rounding off. Okay, 4. 3, 4. Okay.
So,
So h squared now.
yeah, we will,
X squared plus y squared. Pythagorean theorem before you differentiate.
and then differentiating to each dh over dt.
Okay.
Since
Then,
it's a constant again, this is 0. Cancel.
okay.
So we can substitute. Simplify this already to h.
Okay. 2 multiplied by h is equal to okay, 20,000 multiplied by 200. No, Josh, use a parenthesis, Josh, not the dot. Use a parenthesis for multiplication, not a dot.
Isolating dh dt.
Okay, so we arrived at the same answer. So it's up to you which you prefer the 2 solutions. But I'd prefer that. It's simpler than the other one. Okay, since you may forget differentiating the 2 variables in the other solution. Okay, but it's the same answer, Josh, right? Same answer. Okay, so it's up to you which solution you want. Okay, we have another problem. It's a triangle problem. Okay, so it's a cone, but it's still a triangle when looking at it, sectioning it. Okay, it's a triangle. So it stays as a water tank, an inverted cone. with a radius of 2 meters and a height of 4 meters. If the water is pumped in at a rate of 2 cubic meters per minute, find the rate at which the water level is rising when the water is 3 meters deep. Okay, so show the illustration, Josh. Okay, ito daw. May color pa yung water. Yan. May color pa. Meron, tawag doon, meron pa siyang parang splash. Pagbagsak ka ng tubig.
Ayun, fixed.
Josh, could I add to the illustration? Could you draw a straight line from the center of the cone, the 2 meters, the top, until the center of the cone? So as, yun. And then the radius, could you draw a line of the water, the radius? Yeah, okay, so we could identify the triangle. Okay. Okay, so we could identify the triangles we're going to be using. Okay. Nice.
Radius water. Ano pa yun? Radius water. Unknown.
Okay. Drawing the similar triangles of not to skid.
Technology.
Nawala. Nada po sobrang naalala. Meters, 3 meters. Mas mahaba. 4 meters, 3 meters. Tapos yun. 2 meters.
Ooh.
4. And then, find the rate at which the water level dapat
R.
right.
Just your radius.
So we don't know this yet. 2 over 4 equals x over 3.
Wait, Josh, wait. Where's X there, Josh? Wait.
What's X?
Wait. Where's X
Leave
in
it.
the illustration? And no, wait, Josh. The problem states find the rate at which the water level is rising. So you're looking for DHDT. You don't have any height in your variables. Do not use the value of 3 meters. Right, age, the variable. Wait for a while. Sorry about that. We had a visitor. Josh, wait. Okay, going back. Don't use the 3 meters first. Use age, since you need to have a value of the HDT, since you're looking for the rate at which the water level rises. Okay, now equate it with the larger triangle.
R C equals
Josh, don't cut the solution. Do not cut the solution.
Sure.
Show the two triangles.
Saan ganyan?
4 is 2 times 2.
Josh, no. Josh, show your equations. So the relationship between the two triangles. So it's either 4/2 divided by h over r. Okay, or vice versa. Okay, so your height and then your r. Okay, height over r. Okay. There. So you're looking for you're going to change r with h. Okay, so your r now is equal to no, Josh, wait, Josh. Change r to h, since you're looking for dH/dt. You're looking for the level of water rising. So you're looking for the height. Okay. Okay. One over 12.
Pi. Sino po may pi?
Okay. Pi over 12. Okay.
So, differentiating. So, the 3 will go away. So, we're looking for the HDT. I'll just continue with the next equation. So, equals 2 pi over 4 squared over so dV dt is 2. 2 equals pi over 4. Then current H is 2.
Yes, 3 meters.
3 squared. Therefore, dV equals 9 pi over 4.
Josh, don't use the calculator first. Show the solution when you cross multiply the values. dH/dt is equal to Okay. Okay. So let's see if it's possible. Okay, the ratio of change in height is 0.83 minutes per second as you pour in 2 cubic meters per minute. Is it in minute, Josh? Is your unit in minutes?
Abo.
Your value, the answer. And finally, okay, don't change the page. You should show us where you got the 4, the value of pi over 4. Where did you get the value of pi over 4 in the solution? Your solution is lacking. Okay. Okay. So canceling 3. Okay. So I think the next page is equal to pi over 4 h squared. Okay. So I think it's complete. Okay. I think solution is complete. Okay, I think that wraps up our problem for triangles. Okay. So but we are going to introduce one more problem, Josh, in circles. It's a very simple problem just by differentiating the formula of a circle. Okay, so it states that now this will be our topic for next meeting. We'll be solving problems regarding circles and volumes and surface areas. So first is we introduce first the formula of the circle and differentiating given a certain rate of change. If the radius of a circle increases at the rate of 0.01 inch per second. Okay, so the radius is increasing. Find the rate of the area when the radius is 8 inches long. Okay, Josh, illustration. Okay, this is a simple problem just using the formula of a circle. Area is equal to pi r squared. Okay, so differentiating r dt is equal to pi, okay, dr dt. Okay, okay, dA dt is equal to 2 multiplied by pi and radius of 8. Then change in rate is 0.01. Okay, so change in area is equal to 0.16 pi. This is in inch per second, Josh. Okay. So this is an introduction on our next topic on circles, volume, and surface area. The simple problem of just the area of a circle and the radius increasing at a given rate. Okay, so I think that's all for now, Josh. We'll meet again next meeting where we discuss time rates again for circles and cubes and so on for volumes. Okay, so I think that's all for today. I think it's getting late. Okay, thank you very much, Josh.
Thank you po.
Thank you po.
Thank you. Bye-bye.